Welcome to Classes and Methods lecture. So in this lecture we're going to cover the following: classes, attributes and methods, self-parameter, the difference between functions and methods, instances of a class, attributes of classes and instances, and lastly, decorators inside of classes. So what is OOP? Well, OOP is short for Object-Oriented Programming and is essential for any programming language. OOP works with objects, and everything in Python is an object. So objects can be a book, car, or person, and is composed of methods and attributes. So say we have object 1 is a cat, and the methods are meow, purr, jump, eat, the kind of actions you'd associate with a cat. So methods are essentially the doing or action of the cat object. And then with the attributes, we have color, size, weight, age, name, and so on. And the attributes are essentially the description of what the cat object is. And then with object 2, we have a tank, and the methods are shoot, reload, drive, and so on. And then the attributes are color, size, model, and speed. Now classes help to keep all the methods and attributes organized for an object. Okay. Let's create our very first class. It's going to be very simple. What we'll do is class C1 colon, and then we'll have some class attributes. So we'll have x equals, let's say 2.5, then y equals, let's say star, so we have a string, and then z equals 900. So we have a mix of different variables here, a float, a string, and an integer, and they're all class attributes. Okay, so I'm about to do C1. Run this as it is, I get this strange output here, and it's _main _dot_c1, and from now on I'm just going to refer to this as main to avoid saying the double underscores. So main.c1, what is this exactly? Well, if we were to do, let's say, a function here, and when a function is inside of a class, it's called a method. We'll just call this, let's say, check, and print. Let's do I'm inside the class, and also I'll do def outsider print I'm outside. Well, that's okay. So if we just take a look now, dot tab, you can see I have check MRO, which we'll look at later, x, y, and z. So we have our class attributes, and we have two functions here which are actually methods. Okay, so if I were to do, let's say, check, you can see I have function main.c1.check. And the reason for this particular arrangement is because check, which is our method, is defined and created inside of our class C1. And C1, likewise, is defined and created inside of our main. And main is a scope where we define any kind of objects. So if I were to do, let's say, outsider, of course if I just run this with the parentheses, I get, of course, the output I'm outside. But if I do without it, I have, similarly to what we had before, we have function main.outsider. That's because the outsider function has been defined directly in the main scope. And the main scope is the Jupyter Notebook kernel here, where we're defining any of these classes, any of these functions, any object at all within Python, because remember, everything inside of Python is an object. Okay, so let's say I was to do D1 equal to C1, and also D2 equal to C1. And what we've done is have two instances created, and instances are actually objects. So if I do just left tab, and hold the control button at the same time, then print, and we'll do, let's say, C1, and then put this to D1 and D2 if we want. Okay, so what we have here is class, so main.c1, but then we also have main.c1 objects in both cases here, in a particular location in memory, and that's because D1 and D2 are also objects, and these are instances, and to create an instance is called instantiation. Okay, so we take a look at D1 and D2. So d1.tab, you can see that I have x and z, but I don't have the MRO, and I'll look at that in a moment. And then we have the check method as well, just like we have with d2, the exact same arrangement here with the same class attributes, and we have the method. Alright, so what I can do is to say A, I'm going to get, that should be x 2.5, then y is star or string, and then z is 900. Now if I do A, let's say I have, let's do 200, and I'll do D2, let's do B equals, let's say a list, and let's say D2.C equals, let's say cat. Okay. And if I do D2.tab, you can see that I have A, B, and C, which are the instance attributes, as opposed to the X, Y, and Z, which were the original class attributes of our class C1. Okay, and they're not found, of course, in D1. You only have the original class attributes and the method check. So, let's say I was to use a built-in Python function called isInstance. And if I do D1 C1, I'm going to get a Boolean output of true. Just as if I were to do D2, get the same output of true, because D2 and D1 are instances of C1. They were derived from the class C1. But if I were to do, let's say, the integer 10, I'm going to get false instead. And that's because, of course, 10 was not defined as part of being C1 or class. But if I do ints, I get true. And if I have to change this to floats, of course I'm going to get a false. But if I do, let's say, 2.0, I get true. And let's say I was to do D2.B, of course I'll get a false. But if I do list, because list is a class, you can see I get true here. Alright, so moving on from that, I can actually do C1.tab. You can see I have MRO. So let's take a look at this. You can see it's function C1.MRO. And MRO is something we'll cover actually in a future lecture for inheritance. But what it means is method resolution order. And if I do parentheses, I just get main.c object. And that's because, of course, the C1 class is an object as well, just like D1 and D2 is. Alright, and just like I can with D1 and D2, where I can actually add new attributes, I can do it here as well. So we'll do toy equals, let's say, car, and C1.toy2 equals robots, run that. C1.tab, you can see I now have toy and toy2, so we do toy2, we get robot here. Alright, so moving on from that, let's say I want to recreate my class 1, but this time I'm going to add also a docstring, just like you can with a function. You can describe what a function is, but you can also describe what also a class is. So this is my first class, and then we'll have, let's say, def, that can be, let's say, cool self this time. It's the self parameter we'll touch in a moment, but for now, for in range, let's just do 2, something really simple. Print I, and also print end of loop. Okay, and if I want to do C equals C1, run that. Now if I do C dot cool, run this, I get, of course, the output of the loop, 0, 1, and end of loop. Now if I want to do it with C1 directly, dot cool, I'm going to get an error here, a type error. And what it says is missing one required positional argument self. So self is the parameter that's referring to the class C1. So what you need to do is put the instance of C1 inside as the parameter. And there you have the output. Alternatively, if we get rid of the self, and I run this, and then I do this, I'm going to get an error. But if I get rid of the C, you can see that it works. But if I do C.cool, I get an error here. So normally we have it this way when we're creating instances. and all I'm going to do is self. Okay, and now this should work, and I'll of course have to put in the C here. Okay, so let's say I was to just take a look here. We have a bound method, and that's because the C instance has the function cool, which is a method bound to the instance which was derived from the class C1. Whereas if I were to do C1.cool, I get function. What this means essentially is that the function, or rather method, cool, is directly called from C1 class, whereas with the C instance, it has to be called via the class C1. And that's why we have a bound method C1.cool. Okay. Now, I can actually add, just like with an attribute, I can add a function into a class or into an instance. So we'll do, let's say, def greets print hi there, and then I'll do, let's say, c.func1 equals greets, and also do c1.func2 equals greets. Okay, and if I do c.func1, I get hi there. And similarly, if I do c1.func2, I also get hi there as well. Okay, and if I take a look without the parentheses, I get function main.greets, and that's similar to what we had before with the outsider, if I recall. And outside, as you can see, is exactly the same arrangement here. And similarly, if I were to do c.func1, you can see I get the exact same structure here. Okay, so moving on from that, let's create an entirely new class. It's going to be class c2 colon another doc string. This is my second class, and we're just going to add three methods for now. And that's going to be def person, and we'll have self x equals 300 colon print I'm plus string x plus years old. I want to do print as well, just to make some space there. We'll create two more methods. It's going to be, let's say, outsider self name, and that will be print is an outsider dot format name, and then lastly def insider, that's going to be self name equals Peter, print is inside the class dot format name. Okay, so we'll just start with these three methods. We'll add two more in a moment. And if I do c equals c2, and also if I just take a look at c2, then hit shift and tab, you can see I have this is my second class, just like we have with any kind of function. Alright, now if I do c.person, run this, I get I'm 300 years old. Of course, I'm not actually that old. And similarly, if I do c2.person, then I of course have to put in the C instance, I get the same output here. Okay, and I can change this of course to, let's say, 450, or if I want to with this one, I can do, let's say, 26 or 27. I'm 27 years old. Alright, and let's take a look at the other two methods that we have, and they are c.outsider, and of course if I run this I'm going to get an error because I have to define the name. Let's say Mike's an outsider, but if I do c.insider, of course the name is already defined. Alright, so let's say we want to create a decorator. But before I do that, I'm going to actually create a function called square. So square, and it's going to have self, of course, and num, pretty standard really, return num squared. And then we'll do our decorator, so decor1, and that's going to have self, then func, and then we'll have to print decorator1 inside of a class. And then we'll do def, it's going to be, let's just say check args, quargs, and then we'll do, let's say f equals func args, just like before, quargs. Then we'll have a for loop, so for I in range f, print I, and we'll have statements equal to the final value is, and then we'll do return statements, and lastly return check. Okay, so we're going to go about using our decorator, and we're just going to remove these two methods. Alright, so I'll do C, before I do that, let's do C dots. You can see I have the square. If I do 3, of course, I'm going to get 9. Now if I do D equals C dot decorator, then we'll do C dot square. Okay, decorator 1 inside of a class. If I do D, let's say 3, that's going to be for I in range 9. You have 0 to 8, where the final value is 9. Alright, and lastly, let's say I want to create another function. So cube num, and we'll have return num cubed. Okay, and then I'll do C dot func equals cube, and then I'll do D2 equals C dot decorator, then C dot func. Well, that's, you have decorator 1 inside of a class, just like before, and this time it's going to be a fair bit longer the output. So D2 with the same number of 3, it's going to be 27. So 3 cubed, or 3 raised to the power of 3, is going to be 27. So you get 0 all the way to 26 with the final value of 27. Okay, so that concludes my lecture on the introduction to classes and methods. I hope this has been insightful, and in the next lecture we're going to be covering initializing objects. If you have any questions, feel free to ask in the Q&A. Thank you.